Radicals. A radical is any square root. So the square root of a equals b implies that the uh, implies that b squared equals a. We saw this in when we studied the nth root of a, and the nth root of a was equal to b implied that b to the power of n equals a. Well, here the n is actually 2. Now we don't actually have to write it down because whenever there's nothing written on top of the square root, then we assume that it's a 2. And we call the square roots radicals. So this can be read as the radical of a equals b. And an interesting way of visualizing this is if I say that you've got a square and every length is of length b, then b times b, which is b squared, uh, is the area of this square. But let's call the area of the square a. So if b times b, which is b squared, gives you a, then asking for the square root of a is like saying, okay, if I know the area of this square, give me just one of the length of that square. A quick numerical example is if I have, for example, b equals 2, then 2 times 2 is 4. So 4 is the area of my square, and if I take the square root of 4, I should get 2, which is just the length of one of the sides. So here are some of the properties of radicals, and these properties follow directly from the exponent laws. So if I have some number times another number underneath a radical, then this is the same thing as saying the square root of a times the square root of b. And this comes from the law that if I have a times b to the power of 1/2, remember 1/2 is another way of representing the square root, then this is the same thing as saying a to the power of 1/2 times b to the power of 1/2. Now this is by distribution of the exponent into the brackets. This is also true for fractions. So if I have a divided by b in the square root, then this is the same thing as square root of a divided by the square root of b. And this also comes from the distribution law a over b, so the distribution law of exponents. A over b to the power of 1/2 is equal to a to the power of 1/2 over b to the power of 1/2. So what I did is I distributed the 1/2 to the numerator and to the denominator. Please note that a plus or minus b in a square root is not equal to the square root of a plus or minus the square root of b. So it's false. It's false if you do square root of a plus or minus b equals square root of a plus or minus square root of b. You cannot write these as equal. Make a quick note. I'm going to make this note in a different color. So note, if I have a times the square root of b, then, and of course a is a positive number. Let's make a positive number, so a is greater than 0. Then I can write a as a squared square root, right? So this is the same thing as a times the square root of b. Now, using this first property over here, I can recombine this as a squared times b all underneath the same radical. So if you have a times the square root of b, you can bring the a back into the square root by squaring it. So a quick example, a numerical example of this, if I have 2 times the square root of x, well, this is the same thing as saying square root of 4x.